Hello everyone. In this example, we were asked to solve the given triangle, and so we're given some pieces of information about this triangle, and we want to find out all the other pieces of information. So when we're asked to solve a triangle, it means we want to find all three side lengths as well as all three of those interior angles. So there's going to be 6 pieces of information we need to have in order to solve a triangle. So remember, when it comes to labeling a right triangle, we use a capital letters for the angles, and then opposite of those angles, we use the corresponding lowercase letter. So this is angle B up here, corresponding to side length little b down here. And so half of our information, or half of our triangle, is actually already given to us, right? We can see that side length little c is equal to 65. Side length little a is equal to 30. And our angle C is our 90-degree angle here. So that's going to be 90 degrees. All right, so to solve our triangle now, we have to find these last 3 pieces of information, little side length b and angles A and B. It actually doesn't matter where we decide to start here. We just have to make a choice and keep moving. So one thing we might notice is that, well, we have a right triangle here and we know 2 of the side lengths. So using the Pythagorean theorem, we can find that third remaining side length, right? We know a squared plus b squared is going to give us our hypotenuse, or c squared. So 30 squared plus b squared is equal to 65 squared. So b squared is going to be equal to 65 squared minus 30 squared, and b itself is going to be the square root of that value. And so if we square 65 and subtract away from that 30 squared, we end up with 3,325 underneath our square root. And if we take the time to simplify that radical, it whittles down to 5 times the square root of 133. I don't think it matters if we're exact here on this answer. It's always nice to be exact when we can, but we're going to have to eventually round at some point. And so I didn't give any rounding instructions here, or we weren't given any. So let's stay exact as long as we can. Otherwise, in general, let's go to 2 or 3 decimal places. All right, so we found that missing side length. The last 2 pieces of information we need to find are angle A and angle B. And the way we're going to do that is using our trig functions and eventually our inverse trig functions. So let's go ahead and work towards finding our angle A. And the first thing we're going to have to do is set up a trigonometric equation involving our unknown angle A and some of our other pieces of unknown information. And if we have the choice, I always like to use the given pieces of information. That way, I can avoid maybe compounding an error I might have made in either rounding another value or in finding it incorrectly. So if we want to try to find A using the side length of 30 and the side length of 65, with respect to our angle A, the side length of 30 is opposite of angle A, and the side length of 65 is our hypotenuse. So we want to use one of our trig functions that relates the opposite side to the hypotenuse, and I believe that is our sine function. So if we take sine of our angle A, we're going to get opposite over hypotenuse, or 30 over 65. So now how do we find A itself? We just take sine inverse of each side of our equation, and we find that A is equal to exactly sine inverse of 30 over 65. But here we're going to want to round our answer. And if we use our calculators to assist us in rounding this value, we get about 27.5 degrees. Notice I'm using degrees here and not radians because, well, that first angle we wrote down we said was a 90-degree angle. We could have called it a pi over 2 angle, but typically when we're working with these triangles, things go back to degrees instead of radians. But we always have to be careful with context and the particular problem to make that determination. All right, so we did figure out that angle A is 27.5 degrees, and now we could do something similar for angle B, right? This is the adjacent side and the hypotenuse, so we could set up a cosine equation, but the much simpler way is just to use the fact that all 3 angles in a triangle have to add up to 180 degrees. So once you know 2 of them, you essentially get the third very quickly, almost for free. So if we plug in what we know and what we don't know, we see that 27.5 plus our unknown angle B plus 90 has to equal 180 degrees. All right, so now if we solve this equation for B just by subtracting 90 and 27.5 from each side, we find that B is going to be equal to 60.5 degrees. And we kind of got that from the rounded answer for A, so this is also technically a rounded answer. But we have finished solving this triangle. We found all the side lengths and all the angles using the Pythagorean theorem, as well as some of our inverse trig functions. Solving triangles is going to be an important problem we're going to see several times in this class, and eventually we're also going to figure out how to solve non-right triangles. We'll need things like the law of sines and the law of cosines to help us with that. That's what all this is essentially helping us build towards.